Hello. Eurorack modular power is two things. It's really, really important, and it's also really, really boring. The problem with boring subjects is you tend to ignore them until they become really important. Which is to say, I think it's easy to fixate on all the cool things that we can get for our modular and forget about the stuff behind the panel that actually makes your investment function correctly. We're going to talk about how power gets into your modular case in a good and reliable way. I'm going to explain how to work out how much power you need for your modular synth, the types of different power supplies you can get. We'll talk about ways to avoid digital noise, which you probably don't want. And after I've explained this, I'm actually going to install this Konstant lab power supply into this case that I have. And that power supply has been kindly donated by Konstant Labs. And I said I would feature it in this video. And I'm actually going to talk about why I needed that specific supply for this specific case, because that's a reason that you may well find yourself encountering too. I think the first thing that we should mention just quickly is how power gets into the modules themselves. And then we'll look at how power gets into a case. Here's a excellent module from IntelliGel, and around the back I see a little power inlet. This is where power gets into the module, and power is sent into modules through ribbon cables that look a bit like this. And what I want to do is make the coloured wire match -12 or line or red stripe here. This has been indicated on this module, so I want the red stripe, not like that, and we plug it in like so. So the red stripe is in the same side as this little line that says -12. Great. So what about this other end? Well, this is the subject of the video. So the other end goes into our power supply. And so what does that mean? Well, inside a case, if you have one with it, you might have something like this, which is called a busboard. And we can see on the busboard that it is covered in these little sockets. And if we look, because of this little raised notch, we can see that there is only one way that this will plug in. And if we look on the board, we can actually see that it says red, 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 red on that side. And this is because there is a direction to power. There is a -12 and there is a +12. And what we are doing with this little cable and the red stripe is making sure that the -12 from the supply is going to the -12 in the module here. If we have a flying supply, which we'll look at in a sec, we might have a flying ribbon cable like this. The principle is just the same. This connector goes into this the only way round it can, which is using the little notch here. And if we look, there's a red stripe on this too, which is there to indicate, hey, that's the right way round, bud. And so now if everything's installed correctly, if we turn our power supply on, this module will come to life and MS20 style acid will pour forth. Happy days. So there are two different types of power supply that modular cases can have. One type is what I have in this case at the moment, and that's the type of supply that is actually a little module, and behind the panel it has these flying bus boards just like the one I showed you here. So let's lift this up and have a look inside. This is partly connected because I was building this case and now I'm going to have to gut it. Because what I am going to do in this video is upgrade this from one type of supply to the other. Watch those capacitors. Don't lick them. So this is one type. This is a module. It's 4 HP. And on the back I have places where I can have 2 rows of flying headers. I put this into my empty case. I plug my modules into these headers. I plug a power supply brick, like this one, into the module. And then when this is switched on and this switch is flicked, wow, there's some power in that capacitor. Whoa, don't lick those. This should go off in a second. There she goes. Kids don't do this. Put this in your case first. So the brick actually creates the power itself. And this is a kind of laptop style power supply. And what happens is that this little module converts the sort of voltages and amperages of the laptop style supply into nice plus and minus 12 volt power, which we'll look at in a sec. And so what's this good for? The beauty of this is it's affordable. It's really convenient to install. You don't have to do any screwing or wiring or any futzing. You can build yourself a case by getting rails or even just screwing modules into cardboard if you're a savage like me. And then put something like this in it, power it on, and you've actually got a functioning Eurorack system in a really, really convenient way. Now, the disadvantage of this, the supply, this can only supply a certain amount of power, and internal larger systems that we'll look in a sec can potentially supply much more than this can. But this is scalable too. Just as we saw in this system, I have a 4MS version of the same thing, a row power. And of course, you could just buy more of these and have one at each row to power your system, which is what I've done here. And that's totally doable. Of course, it means buying more of these. It means having multiple bricks hanging out of it. And if portability and using less plugs matters to you, then that's something to consider. And the other thing is the HP. This takes 4 HP. This is another 4 HP. And so it might impact your system. In a very space conscious system like this, I don't want to have space used up by power supplies when I could have one inside using 0 HP. If you look in your favourite Eurorack store, you can also probably find busboard extenders designed to add more sockets than the 5 you see here, so that you can get more modules powered by this thing. But as we'll see in a sec, it's very important that you don't overstretch the power supply. We'll learn how to do that. But what's the other type of supply, and why would I want it? So the other type of supply is something like what I'm about to install. What this takes the form of is a power supply unit, which is basically like a really fat and beefy version of what's inside that uZeus, and with potentially higher grade and higher power components. And so this can power many, many more modules with much more overhead than one uZeus can. But like the uZeus, we still have to get juice into this. We do it with an external socket of some kind. Here's one that you could cut a hole for, screw in. These go into the terminals, and then these terminals then feed the modules, and they do that via bus boards, like the ones we looked at. Konstant labs do one where the sockets go this way and one where the sockets go straight up. And they do that so that you can save space inside the case. That is one big consideration, is even though this is very, very slim in terms of depth, you do need to think a bit about the space behind the modules and making sure you have enough room in your case to fit this stuff underneath them and also feed power to them. The whole uZeus flying busboard way is good in terms of space behind the case. If you're space limited, it can sometimes be an issue where the power supply is placed in the case. So it's just something to think about. Will you have enough clearance under the modules, as module depth varies, to make sure that there's enough room to have everything plugged in? It's likely you will, but it is something that is worth considering to make sure you definitely do. But the advantage of this is the amount of power it can supply, potentially the quality of that power, that is to say its stability, and potentially also a lessened risk of crosstalk and digital noise because of the way this is designed, in that this has 2 sort of separate power rails that are independent from each other, so there is less crosstalk. But above all, the main advantage with this is the amount and the quality of the power and the amount of infrastructure it supports. That is to say, I can have 3 bus boards from this one little thing, all nicely installed behind the scenes, really, really convenient to use. What's the disadvantage? Really, the main disadvantage is cost. Of course, something like this is considerably more expensive than a uZeus. if one is prepared to invest potentially thousands of pounds in modules over the years, is it unreasonable to spend like the cost of one expensive module on the power supply that makes it all work, potentially flawlessly? There's a judgment call that one has to make when we do these things, and it's all very personal, so it's up to you. For me personally, I'm really happy to have a supply like this in my case. It's really what the case is meant to have. And so, okay, there are two different types of power supply. But for both of these types of supply, the really important question is, how do you know that you're buying a power supply with adequate power? What do I mean by this? Well, to introduce this concept is the fact that, of course, all the modules together pull a certain amount of power, don't they? They have to, right? And your power supply has a number on it, 2000 milliamps. And what happens if we go beyond it? What happens if we ask too much of it? And how do we know how much is too much? Okay, let's move to the computer and we'll work this out. All right, to the grid. So this is modulargrid.net, which is a website that's used to plan modular synthesizer systems. And if you don't use it, I really, really recommend it. And it does many useful things, but in this instance, one of the most insanely useful things is down here. If we look very carefully, we can plan a modular synth as we intend to have it, put all the modules that we intend to have in our system in there. And underneath the module itself, or modular, beyond the eye-watering price, which we never look at, don't ever look at that, is a rough estimation of power consumption. 2517 mAh plus 12 volts, 641 mAh minus 12, 0 mAh 5 volt. What is this? So mAh are milliamps. So remember before when we plugged in the module, there was a minus 12 side, that side with the red stripe that we had to get right. And so accordingly, yin and yang, there is a plus 12 side, which is at the opposite end. Now this is because, for whatever weird electrical reason that isn't very important, modular uses two different types of power, negative and positive 12 volts, at the same time. Each module draws a different type of power at the same time, and it draws a different amount of it. If we go and look at a module on a web page, here's the boom, which is this rad kick drum that I want to use, the frontier of kick synthesis. Let's scroll down on the web page to the specs, beyond the men with beards, and here it is, power consumption, The Bohm module needs 130 milliamps of plus 12 to work, and at the same time it also needs 10 milliamps of minus 12 to work. And there is also a thing called plus 5, which it doesn't need any. So actually there's three types of power, and on any module like manual or web page, if you look carefully, you'll find these numbers and the requirement of the module. So we understand a module needs some plus 12, some minus 12, and maybe none or some plus 5. FYI, very few modules require plus 5 volts these days, but some do, older ones especially, so just look out for that. Most power supplies will deliver some. So it's this simple. All of these modules plus amounts needed to be added up, and all of their minus amounts also need to be added up, and any of their 5 volts also need to be added up. Now, a very big consideration is that this number that we see on Modular Grid is obviously based on specs that are in the Modular Grid database, which doesn't necessarily mean they are correct. So you should be cautious about taking this number at absolute face value. And if you were being really, really diligent, what you would do is get an Excel spreadsheet out or, Google Drive sheets, and you'd go on all the various websites and try and find the most reliable information to double check it. That's how much power all of this is going to need to work correctly. So the implication is, what if it doesn't work correctly? What then? Well, the gloves are off. I've had modulars that are underpowered, and it means stuff tends to go weird. When you turn a system on, there is often a kind of high draw in that moment, so things don't turn on properly, or or go weird. It's very hard to say, but the general rule is you want to make sure that your power supply can deliver at least this value and really more. Because the harsh truth is that depends on the manufacturer. I spoke to Konstant about this and they were quite insistent. Konstant Lab have obviously been making supplies for years now. I've had a Konstant supply in my MDLR case that I used a few years ago, which I still have actually, and it's been really good. And they're very insistent on the fact that their systems will deliver the power that the spec says they will, if that makes sense. If they say it delivers this amount of power, then it delivers it at full load for a sustained period. I can't speak to every manufacturer, and that's not me throwing shade on every manufacturer, but I am saying to be realistic that there are tolerances with these things. I would not be surprised to discover that certain supplies might not deliver quite the voltage that they say they do, close to, but maybe not exactly the full amount, and for a sustained period. And that matters for a very important reason. And it's the reason that I've gotten this Konstant Labs 100 watt supply. And that is because that's over 2.5 amps. So let's now go look at this. So here we see that the uZeus can produce 2000 milliamps at plus 12, 500 milliamps at minus 12, and 70 milliamps at plus 5. That's telling you this is what this supply is able to kick out. And that means that that one supply can absolutely not power this whole case. It would fall over because this needs 2500 and 641. No way. This number is smaller than that number. Now, of course, my solution to this before was to use 2 bus boards. So, okay, let's go shopping. So I go to Konstant Labs site and I go, well, I don't want to spend, 490 euros, ideally with that, which is for the 100 watt supply that I have. I want to spend a bit less if that's possible. So they do 2 supplies, a 100 watt and a 70 watt supply. The 70 power is smaller, and let's see how much it kicks out. Aha, here we are. Its plus 12 is 2500 milliamps, its minus 12, 2500 milliamps, and its 5 volt, 2000 milliamps. Very meetsome. However, this number is higher. And if you're really paying attention, you'd notice that they're actually missing modules here. I want to put more stuff in these spaces, and I just want to know that I have the overhead. This number is bigger than 2500. Now we have it on good faith that this will deliver a solid 2500 milliamps sustained. And I do trust Konstant Labs. I am literally going to put this supply in the system and we'll see how well it does. But even so, frustratingly, I need more power than this supply will officially kick out. So I shouldn't be using this supply in my system. I should be using the larger supply. And that is the importance of doing your research. So this does mean I need the more expensive supply. Obviously, it's nice to be able to buy the cheaper thing. I highly doubt that this number is so incorrect that it would in fact be like hundreds of milliamps below. So I personally want to have a supply that I know is going to be adequate. And that's this. It's literally double the power. So this is what we're going with. And that was the reason that I had to go with this supply. So to recap, modules have a plus, modules have a minus, modules might have a 5 volt. You add up all the columns of the pluses, the minuses, and the 5s to get a total sum for each. And just to be clear, the minuses add up. They don't subtract or anything weird like that. You just add up the number. Minus doesn't mean you remove it. You've got to add that one up too. This leads us to a total number of plus, a total number of minus, and a total amount of 5. And then we've got to make sure that our power supplies can deliver at least that amount, because it's possible our power supplies won't be operating at full capacity for the whole time. We've got to build in a bit of overhead to know that the supply is going to be able to kick it out. And so we look on the manufacturer's site to see what can be outputted, and we make sure it's a higher number so that we know we're not going to power starve our system. So I'm not saying you have to get something like this, but just to explain, this is what it exists for. Higher capacities with higher stability and potentially less crosstalk. Very quickly, I just want to mention one gremlin, and that's digital crosstalk. That is the noise that digital modules make when they leak into the audio realm. Interestingly, a mate of mine, Dave, had this recently, and he sent me a WhatsApp message where he was like, "Pop quiz, what's this noise?" You hear that like, that is the sound of digital parts bleeding out of the modules. In this instance, it was a digital sequencer into the analog modules. And so how do you stop this? And I asked Martin from Konstant what he thought. Another question is how to prevent digital noise from penetrating. Well, that's for another book. But the main thing is to use good power supplies, good cabling, and have the system be properly grounded with a plug. This is the case when the sources themselves can interfere. But a common case is when the power supply is clean and some indecent, mostly digital module radiates interference into the power supply, and that digital module interferes with everything else. So for this, they came up with a trick of filtered busboards, where all the modules that interfere or do not mind the interference are connected to the direct section of our busboard, and all the sensitive analog modules that are bothered by interference in the network are connected to the filtered section. The direct and filtered sections are mutually separated by a LC filter that effectively suppresses this interference but can't completely eliminate it. Another option is to use our hammer power, the one I've got, that has a plus 12 divided in two independent sections, plus 12A and B, where clean modules could be in one section and dirty modules in the other. This helps a lot. A similar effect, if you don't own their supplies, can be achieved by using two independent sources. Sometimes a digital module is indecent, naughty, and it can, through design, bleeds into the rest of your system. The simple way to try and work out what it's doing or how that's happening in your system is to disconnect modules one by one. Start with the digital modules, listen to the output. As you disconnect them and power on and check again, wait until the noise disappears. The last thing you disconnected before the noise disappeared is the culprit. And then it might be a case of moving it away. I've heard that it's purported as an idea, but it may well be at worst that you have a separate supply and you kind of quarantine the digital modules on one supply and you have the analog modules on another to separate it. And I think in Dave's case, his way around is just turn it up louder and add more reverb and delay so that you don't notice the noise in the background of all of the wash of noise. Right, onward. Well, this is a bloody mess, isn't it? Now what we're going to do is we're going to install the Konstant lab supply in this case. What we're going to do is actually quite similar to anyone else's internal supply. The principles are basically the same. You've got to get power in, you've got to wire it to the brick. You have a brick, you've got to fix it to the case. You've got to get power from the brick to the busboard. That's the same with that. Or for example, when I first got started, I had a Dupfer DIY power supply. It was exactly the same principle except God bless you, Dieter. The Dupfer one does not have boxed headers, as you see here, which is, you know, that can definitely catch you out, let me tell you. So my strong recommendation is if you're buying busboards, get ones that have boxed headers, mate. It helps, because we all make mistakes. I know I have.
The first thing you should do before any project is have a nice sit down and ensure you've got all the correct tools at your disposal, and then read the manual from start to finish. So you know what you're doing when you come to drill holes in your nice Damaru case. What could possibly go wrong?
I've said it before and I'll say it again, that I love coffee a lot, but if I had to choose between tea and coffee, it's tea. We keep tea. I mentioned busboard extensions before. This is one, by the way. So just know that you can get a little thing that has one socket on one end that goes into an available flying busboard hole, and then that terminates in loads of sockets. Yeah, it's yet another busboard extension that I was using in this case. If ever there was an indication that I was pushing these two row powers a little bit, it'll probably be that. Although it did work, this system, it's more about the space and the overhead. Another thing to say about the uZeus, by the way, is that the uZeus, it's possible to buy a enhanced outer brick for it. That's what this is. This is the 3000 milliamp brick, 3.07 amps, because there's a weaker power supply that comes with it by default. Right, let's take out this fine little dimmer. Yes, there must always be somewhere for tea. Everyone should have a little dish for your screws. I favour the old G-Shock box that my G-Shocks came in. I have a few of those, more than I should have, really. It's a live modular synthesizer. Some assembly required. So this exposes the guts of my case. So this, by the way, is a Damaru case. Damaru. Damaru is the name of a company run by a really nice guy called Aidan, who works out of Elevator Sound in Bristol. And the reason that I have this case is that it's made of like reinforced plastic. The reason I want a plastic case is plastic is lighter than wood. I do not recommend wood cases for portable modular synthesizers because they are unbearably heavy. Buy a case based on lightness first and foremost would be my simple, plaintive piece of advice, because having bought heavy wooden cases before, carrying them is a pig. And so the only other consideration here is the fact that we need to screw these onto this back plate with little standoffs. Now, Aidan from Damaru was super kind, and in supporting this video has actually just sent me some of the standoffs that he uses. And this is especially relevant because Aidan actually uses Konstant lab power supplies in his Damaru cases, and you should be able to buy one from him, and he's done all the installation for you if that is something you prefer. Obviously it costs a bit more, but he'll do it for you, and that is completely understandably something that some people will want. And so the basic principle of what we're about to do is we need to get power from the inlet into this, and then power from this to the boards. And before that, we have to mount the supply and the boards in the case. And now we do that with standoffs. The power supply and the bus boards rest on these little white standoffs, and then you screw the standoffs into the case from the other side to hold them in. Of course, if you have a wooden case, you may approach this slightly differently, but it will be some shade of that. You'll be using standoffs, you'll be affixing the standoffs to the case. And the only other big consideration with where we place these in the case is that thing I was mentioning before about module depths. I made sure that I didn't just get the shallowest case that Aidan can do, and I think you can vary it. You can certainly vary the top lid. So I need to think a bit about this and place these appropriately in the case so that I leave the maximum amount of flexibility to place modules. I have seen boards be offset like this so that you have more depth on one side of the case, but to be honest, like, these are not that deep. It's just something that you should think about. What is the deepest module that you own? Maybe get that module, place it in the case and run it along behind the board with its raised up aspect, because remember, it will be raised off the ground a little bit. Where are you going to put it? It's just worth a little bit of a think. And the other aspect is just the ribbon cables themselves vary in length. These are made by hand by the manufacturer. So sometimes you can find that they're awesome and they give you a really nice long one that can reach anywhere. But if you've only got two bus boards, suddenly it might matter where you place it in the case, and you want it centrally located so that it's never that far from the ribbon. Make sure the clearance has been thought about so that your deepest module can still fit in the case, and also make sure that you've spaced out the bus boards so that the modules you want to install can actually reach them. And if you were absolutely buggered, you could potentially still use an extension, but presumably you want to try and avoid that. So let's have a quick reconnaissance of what we need to do here. So obviously the case itself is now free floating. On the other side, it has this flat plastic. On this side, it has this kind of ribbed, for my pleasure thing. And if we look at this end, here we see that the case itself already has an inlet. Of course, I'm going to use this because this is already nicely integrated into the case. But if you were to get one of these supplies, you'd basically be cutting a hole in it. I'm not sure the best way to do that, if I'm honest. If there's any woodworkers or metal workers or plastic workers here, then maybe they could advise. Now, what Aidan said to do, Aidan is the guy who made this case and installs these power supplies professionally, is Aidan said you use the PCB as a guide, placing it on the opposite side to where you want it to be, right? So say I wanted it here. Then I use this as my drilling guide, these holes. And he said, hold it in place, not vice grip tight, but not loosey-goosey either. You want to basically be holding this in place so that you can then drill through the 4 holes. We can see that the thing itself has got these 4 holes. We want to drill through these, right? And we're going to screw through from this side. So you end up with the 4 screws kind of visible on the case. That's just how it has to be. That's how it works. And we do the same for the PCBs. Right, now I need to really think about where I'm going to put these in the case. Yeah, I think this could kind of be good. I've got the straight up board underneath the 1U because that makes sense. The 1U stuff tends not to be that deep. That feels good to me. And also I wanted actually eat my own dog food here and take the deepest module that I have and just check its depth. Look at this mad lad. This is the Pico DSP with the crazy backpack mod that hacks the Pico DSP to run the Halls of Valhalla card. Anyway, can I do that? Yes, I can. Is there anything going to protrude? No, that's what's so good about these boards is the cables go sideways out. So the cables themselves, it's one thing, especially with these boards with the straight up, you might be like, oh, you know, it fits under there, no probs. But then suddenly once you actually add the cables in, and sometimes the module themselves have the cable attached here, you find that, oh, with the cables, it doesn't fit. So just bear that in mind. Right, here's this IntelliGel module. Excuse me. Even with those plugged in, totally fine. It's fine. It's totally fine. Oh, my poor little squirrel. Little nutkin. Come back, fella. At the risk of screwing up, I think I'm going to screw in. Actually, before I do that, does anyone spot my mistake? What was the dumb thing that I just did? Which was that I just checked the module depth was fine with these without a standoff placed in the PCB. The standoff adds 5 millimeters to the depth. I mean, I don't really have a choice here, so I think it's going to have to be fine. But I just want to point that out. It's check with the standoff in place. Additional height will be added by the standoff. I am dumb. Be careful. I was just reading the manual, and there's actually one other thing that we should say about these boards as well, which is visible if you have sight. That if we look carefully on the boards, it actually says filtered and direct. So the idea is that you are better off putting your digital modules in the filtered side and the direct can take the others. And so this orientation where I have the filtered on the left, I'm going to keep that. Yep, because in my live modular system, I love digital oscillators. And I generally do left to right. So I'm going to probably end up with digital oscillators around here. And I've got my Droid system to go in here, which is also incredibly digital. And so that's going to go on the left too. So that's fine. There'll be digital is kind of here and analog is here. In the real world, it might not make the biggest differences. You might find that you've got no issues as well. It's the same here, actually. Oh, that's good as well. I'll put the filtered on that side. So there's always some filtered, because I also have like the Endorphins Golden Master, which is digital. Okay, interesting as well. There's these dip switches on the boards. The dip switches are basically due to the filtration. They're on with 2 switches on for each side by default. You can switch more on if you want more filtration, but there is a bit of a trade-off to do with high inrush current during starting sequence of PSU. Some PSU can have issues with starting because of high capacitor charging current. Switching dip off can help improve PSU behavior during the start. So let's leave it at the default. But we know if I was having trouble with digital noise, there is something I can try here, which is switch more of these on. It's actually really good. My other power supply did not do this. Right. So to do this drilling, I'm actually going to use a 3mm nice wood drill bit that I've got. It's about right. I'm confident that they should hopefully stay in once drilled, because that would be the main thing, is I don't want them to come out once they're in. Oi. That's a screw. Bye. That's basically what we have from the other side. And if I'm not mistaken, these are symmetrical. The symmetrical, therefore, if I do that, that's your huckleberry. So I think you just drill, don't you? I just think you drill, baby, drill. What could possibly go wrong? Get hold of it, be loose but not goose, and just drill through the mother hub hard. That's not straight, is it? I've got a right angle thing. Hang on. Here is my set square thing and some blue tack. I'm no Adam Savage, that's for dang sure, though I do have glasses. Hold it not too loosey-goosey, not too righty-tighty. Drill once, regret for a long time, I think is the phrase. Drill 8 times, regret infinitely your drilling. It's time. Let's drill through my modular case worth several £100. Ah, that's easy. Okay. And let's drill through the modular case worth several £100 plus tariffs. I'm really glad that I did the blue tack thing. That feels like an innovation. Wait, what was that? Don't move. Okay. In this instance, what does a reasonable person do? Do they stop and turn it over and check their work, or do they just plough on doing more drilling, proud in the knowledge they've probably done it right? I mean, they're holes. The holes are in the case. I think this is symmetrical. It should line up equally on the opposite side, right? It is. It's very light. It's just plastic, so it's dead easy to drill through. So that bit is good. And I'm going to I want to not cock this up more than I likely already have. Hold on to your butts. Hey. That's yes. What I would also say is the advantage of a wood screw. I don't know if you can see this, that the wood screw, maybe you can't see it. Basically, the wood screw has got a sharp little point at the end, which is super useful because it means that when you place it in the center, the sharp point goes into the plastic. Just, Alex, would you please stop powering it through? Just, yeah, a light touch. I think we can just carry on. This seems fine. Feels good, man. Feels good. Just carry on. Just don't check. Don't stop and check. Fortune favours the brave. Come on. We've got homes to go to. Oh, I hope I've not fucked this up. Do I have OCD? No. I'm much too messy. Well, friends, to my best of my abilities, I think we've got this reasonably straight. It doesn't actually matter if it is perfectly straight. Oh God, is it straight? Oh my God. The simple way to check is take a British Rexel small paper clips packaging and hold it to the edge using this sort of inner lip as a reference and check that the height is the same, more or less, along the whole length. I think we're down a little on this side. Anyway, I'm not going to see it because this is going to be facing down and away from me at all times. But I'll feel it, you know? I'll just kind of feel it. I'll know that it's like this, and I won't be able to relax. Yahtzee. I mean, that's the whole hole there, isn't it? So that's just ridiculous, but let's just go with that, shall we? Right, for better or worse, and let's hope better, Blinking Blonking screwed it, mate. Holy case, Batman. Did I make a mistake and do it completely on the wrong side? No, I didn't. So the power supply is going to go on this side. That's good. Pro tip is to get rid of these sort of little plastic greeblies, which you want to do because we want our little standoffs to sit flush. Pliers. Pull them off. There you go. Just pull them off, yeah. Right. So here's my well-peppered case. A lot of very carefully aimed bullet holes have penetrated the beautiful plastic exterior. So yeah, now what we need to do is insert some standoffs and screws, right? So how's this going to work? Very simply, that what we're looking at here, this is going to go in there, and it does. Excellent. It protrudeth in a manner that is difficult to access. However, with some care, and I'm pressing my finger on the other side of it just to get it finger tight. That's your huckleberry, mate. Okay, now I have to do this about 47,000 times. I'm not going to go mad with over tightening this, like holding with a pair of pliers and tightening them in. Maybe I will do that, but I will be gentle. I will stop when it stops turning because I don't want to strip the threads. The chaff is actually holding the screws in really well. So what I'm going to do is I'm going to put all the screws into the back loosely. I don't think they're going to fall out. Then I'm going to turn the case over and screw in the standoffs. And it was at this point I realised he didn't send enough screws for me to install all the bus boards that are on this thing. Because there's loads, I've actually got 3 bus boards. So I'm actually, annoyingly, 1, 2, 3, 4, I'm 4 short. We'll pause here and I will get some more. And we'll return. Moving on. 1.5 weeks later. Thanks, Aidan. Right, let's put these in. Man, like doing jobs like this, which of course is the job that would be done by Aidan if he bought one of these cases, it is a interesting reminder of the amount of like tedious work that goes into building things. You know, you would look at a modular case and sort of you foolishly think like, why is that worth a few £100 when it's just a box, right? It's like a machine just kind of pumps that out. But until you do it yourself, and I've got to like individually insert and screw and drill and prepare and measure and check and tighten and check 48 screws, or 28 actually. It's actually quite a lot of, like, it just takes time. It's not necessarily hard, but it does take time. Imagine if this was your livelihood. How much time in the day do you have to build these things? Oh man, it just gives me, yeah, a real appreciation for small manufacturing industries, what we think something should cost. It's very hard for us to perceive the amount of time and effort that goes into something, you know. Done. And around the back, what a little... Anyway, this has got to go in here, this way. And if I've done this correctly, I should just be able to go, boop. Wait, it just pops in. I think it was this way, wasn't it? Direct near the PSU, filtered on the opposite side for the digital stuff. That is going to go. Oh, is that going to line up? What the shit? It's totally different. What? It's totally wrong. Oh no. No. How did I get this so wrong? That one is fine. And of course this only goes that way. Oh, I'm a fool. There we go. That one's in. Why is this not lining up? Wait, that is lining up. Okay. Whee! That one's in. So 2 boards and a power in. What has gone on here? Mr. Melodies, you have effed this. Absolute clown. I've got it completely wrong. Okay, there's nothing else I can do. All I'm going to do is undo these, re-drill the holes, shift it to the side, and we end up with speed holes in the back of the case, you know, to make it go faster. I found out what I did. I look back at the footage because, of course, I filmed myself doing this whole process. And my mistake is very simple indeed. When I measured that section of the case to put the busboard on, let's look at the footage. What's wrong with this picture? Here's the busboard that I want to put there. Uh-oh, what's this? I used the wrong busboard to measure it, and the holes are in a different place with the one with the sockets going straight up versus this one with the sockets flat. So don't do what I do. Let this be a lesson to you, dummy. Use the correct busboard to measure because the holes are in different places for these 2 boards. I'll tell you one thing though. My case is going to be holy. Yeah, I'm a dumb guy who makes stupid mistakes. What an idiot. I don't know what I'm doing. Not paying attention and doing stupid stuff. That's how it works. I just can't get enough. God, I'm an idiot.
This is why you should leave this to the professionals.
Wait. Yes. Yes. Most indubitably so. Scrape my chaff off. I mean, mate, this is shifted. Right, anyway, I'm going to put screws in these holes and test the lineup. Okay, I've put screws in the new holes. Let's turn it over and see, does the busboard sit upon the holes or upon the screws?
Kind of. What? Yeah, it kind of does. One looks like it's off. Oh, Alex. Mate.
Okay, I'm going to put standoffs on these and assess. Right, Maybe with a judicious... Hey! No! Hey! Hey! Just stretch it. Okay. No, it is okay. There we go. All the boards are in. And looking good. This top one is shifted a little, but let's say that that was intentional. This is just a little visual reminder. Every time I can look at this, I can think to be careful. Now the wiring. So then, wiring. And we can see from the little drawing, it advises us how we do this. We're going to split off from the main supply in two different ways. So the main supply supplies 5 amps by supplying 2 sets of 2.5 amps. And so the idea is if you had 4 boards, you'd send half, one of the outputs would go to one set of 2 and the other outputs would go to the other set of 2. I obviously don't have 4 boards, so I'm just going to pick, one of the outputs is going to go to one board and the other output is going to go to 2 of the boards. And you just chain them. So we chain them together. And what we need to do is we need to strip these wires, cut them, strip their ends with a stripper. And I happen to have one. Oh, look at this. And some snippers. And that should be all we need. No soldering. We have to put the power into here. Minus, plus, plus. Why is there 2? Maybe that's so you can have 2 sets of inlets? I don't know, for like more power. But these are weird. And the way it works is you kind of push, you rock them backwards. They're really stiff, but you push them backwards with a screwdriver like this. They open up and you'd be able to push these in and then release and it's captive. So you don't need to solder. And the other ones, a little bit different, I think, but similar sort of idea. These little doofers. I think we... oh, no, I might be doing that wrong. If these push down, I think that's it. We create this little chain. And so that's what we're going to do. But first, I'm British, so we drink tea. Cup of tea. Ah, it's Yorkshire. Don't put tea on your circuits. Did I just put tea on my circuits? Tea on my circuits, the Milo Melodies story. Right, first thing I'm going to do is I'm going to plug in the power into the inlet. Give her a twistaroo. There we go. I actually have the sound of Doppler effect in my headphones, which I'm not playing into the room in order to not get a copyright strike from Gerald Donald. It feels very futuristic, building my synthesizer, listening to icy electronics. Okay, I think that's there, right? I have another little thing, which was a gift from Konstant, which is this sweet little 1U module. Look at this little guy. It's a 1U power checker. It's just a bit of an early warning radar for your modular. Is something going wrong? If so, these will not be lit. And I'm just thinking at this stage that I might just try it. Here's the behemoth of a power supply. Wow, look at this unit. 6 amps. And also, I've already labelled it. When you're in a club and you're like, this one's mine. When I'm at home, what's this for? I mean, I don't have another one this big, but mate, get a label maker. Label your cables. Let's just plug it in. Hey! Hey, baby! And that is the point of this. If we look on the thing itself, excuse me, let me fly you over here. But on the unit itself, it also has indicators and we can see all the lights are lit. That's good. Currently listening to the album Cellular Automata by Doppler Effect, which I will link to below. Something measure how many times? Said to give 7 mil in the thing. Not the world's best. Oh yeah. You have to do that. To make this easier, and just because this is too small to see, I've created a little code. Black cable is 5, red cable is +12, white cable is ground, blue cable is -12. Okay. Okay. Oh, yeah. Yes. Boy. Yeah. Little Neapolitan baby. Okay. Oh, you did it. Did you? I mean, it's a thing. I can't help but notice that we've done this. That's done. Now, cable ties. Well, okay. Did it. It's connected. Okay, let's power it up. Sorry, excuse my big head. -5 is to -5, yes. It goes black, red, white, blue. And then this goes along here to here. Yeah. This inverts here and here. Black, red, white, blue. Black, red, white, blue. That way round, yes. And that's the same on the top as it is the bottom. Black, red, white, blue. Okay, don't blow up. Hey! Yes, mate, look at that. And the lights on the bus boards. Isn't that a lovely feature? 3 lights on all the bus boards is a promising sign. Also a promising sign. All the lights on the power board. Additionally, promising sign. My friends, we did it. We've built a working Eurorack case with a big fat power supply. Sure, the case is a little bit holy, but a little blessing to take me on my modular journey, I see is no bad thing. The only thing that I don't enormously like is that this, I can just literally see the terminals there. If my finger went a couple of centimeters forward, I'd be touching the inlet. So what I'm going to do is I've got some electrical tape and I'm going to wrap some of the exposed bits because I don't like that. But friends, I'll leave you with a little montage as we put the modules in.
What's next? Practice.
See you soon.